Can I have the response? Is it visible? Thank you, Kavya. Okay, let's start today's session. So, good evening, participants. I welcome all the participants for the day 27th for the course Cyber Security. So, for today's session, we are going to deal with the topic asymmetric key cryptography algorithm. That is, one such algorithm is RSA algorithm. RSA algorithm. Okay, we are going to deal with the algorithm and how to solve the algorithm with an example. Okay, so the objective of the session is to make you known about the asymmetric key cryptography algorithm, that is RSA algorithm. Okay, and the outcome of the session is that the students may be able to understand the asymmetric key cryptography algorithm, that is RSA algorithm. Okay, and the outline of today's session is we are going to discuss the RSA algorithm and what are the applications of RSA algorithm, what are the advantages, disadvantages, and how the RSA algorithm works with an example. Okay, so this is what the plan today. Okay, so here you can have RSA algorithm is a asymmetric key cryptography algorithm, and it was named by the three persons, Ron Rivers, Adi Shamir, and Len Adelman. These are the three persons who developed the RSA algorithm. Okay. So from their first letter of their names, it has been coined as RSA algorithm. Okay. And this RSA algorithm was most popular and proven asymmetric key cryptography algorithm. So this is basically it is based on the mathematical fact that is easy to find the and multiply the large prime numbers together, but it is difficult to factor their product. Okay. Okay. See how the RSA algorithm works, or how the asymmetric key cryptography algorithm works. We'll see. Suppose the case is Alice needs to communicate with the Bob. So if this is the case, they have to go for encryption and decryption methods. Okay. So if they're see here, KE is representing the public key that is used for the encryption, and KD is representing the private key that is used for the decryption purpose. Okay. Okay, fine. Now, so Alice is going to have the plain text. So this was the text to be transmitted. So with the plain text, and the KE is the public key which is used for encryption. So with these two plain text and the encryption key, that is the public key, it is converted into ciphertext, CT. Okay, fine. So then that CT was passed on to the internet, and on the other side, the Bob will be receiving the ciphertext. So he will be using the private key, that is KD, for decryption purpose, and using that with the decryption key KD and the ciphertext, he will go on decrypt and get the plain text, original plain text again. Okay. And if Bob wants to send message to the Alice, then means, if it is the case, means Bob will be using the plain text and he'll be using the public key. With these plain text and public key, he will convert into ciphertext, and that will be passed on to the internet, and that ciphertext will be received by the Alice. And with the ciphertext, Alice will be using the decryption key, that is the private key, to convert into plain text. So in this way, Bob and Alice will be transfer the messages between them. So Alice and Bob will be having both the keys. One is the public key for use for encryption, the other key private key for decryption. Okay. So this what happens in both at the encryption point and the decryption point. Okay. So coming on to the application where we can apply this RSA algorithm. The point is that RSA has been used extensively in various applications from Bluetooth, Mastercard, Visa, e-banking, uh, e-communication, e-commerce platform. Okay, so RSA was the first algorithm which supported secure communication without a shared key, where the encryption is very easy to implement and the decryption process is very hard without the private key. Okay, so and where we can so coming on to the advantage of RSA. So RSA algorithm is the implementation part is very fast. We can execute or implement the RSA algorithm in a fast manner, and it is a very simple encryption methodology and verification also. Okay, and the next point, it is easier to implement than the elliptical curve cryptography algorithm that we call it as by short ECC algorithm. So that is one of the algorithm of asymmetric key cryptography. So when compared to RSA, so ECC, RSA is very easy to implement. Okay. So then it is also very easier to understand the algorithm also, and it is widely deployed and better. It has the better support, industry support also. So these are the points to be important points for the advantages of the RSA. Coming on to the disadvantages, while moving into disadvantages, it is a very slow in key generation process. Okay, so what are the keys to be generated in RSA? So that is two keys must be generated. One is the public key and the other one is the private key. So these two key generation, it takes a very long time. That is very slow in key generation process. Okay, fine. The next disadvantage is slow decryption, which is slightly tricky to implement securely. So the decryption is carried out with the private key. So this is done in a slow process. Decryption is done in a slow process. This was the disadvantages of RSA. Okay, fine. Let's move into the algorithm. So these are the three persons. They RSA that come from the first letter of their surnames reversed Sharmer Adelman, RSA. Okay. So coming on to the algorithm, the first step is finding the modulus. Okay, finding the modulus, that is RSA modulus. So first we have to select the two random prime numbers. Okay, so let the prime numbers be P and Q. Okay. So for example, we can consider the prime number 11 is taken for P and 5 is taken for Q. Okay. So what the thing we have to, after choose the two random prime numbers, we have to go for calculating the RSA modulus. So how will we calculate the RSA modulus? That is by multiplying the P and Q. So that is RSA modulus. So n is the modulus, that is RSA modulus. N equals P into Q. So we have taken 11 as P value and 5 as Q value. 11 into 5 will get the N value as 55. Okay, fine. So the next step. So first we have to choose the random prime numbers P and Q. And after choosing, you have to go for calculating the RSA modulus from the formula N equals P cross Q. Okay. So we are getting the RLS modulus value as 55. That is the n value. Next step, we have to calculate the Euler's torsion function. Okay. So how will we calculate Euler's torsion function? So with the formula pi of n. So Euler's torsion function is otherwise called as pi function. Okay, fine. So pi of n equals p minus 1 into q minus 1. This is the formula to calculate the Euler's torsion function. So what is this Euler's torsion function? So in number theory, Euler's torsion function counts the number of integers from 1 and n. Number of integers between 1 and n. So which are co-prime to n. Okay. So Euler's torsion function is also known as pi function, which is a multiplicative function, meaning that if two numbers m and n are relatively prime, then pi of mn equals pi of m into pi of n. Okay. So in other words, we can say Euler's torsion function will use for counting the number of integers between 1 and n. So which should be co-prime to n. So if the two numbers are co-prime, if their greatest common divisor equals 1, then 1 is considered to be the co-prime to any number. Okay, fine. That's the story. Okay, leave it. The second step is to calculate the Euler's torsion function. Okay. So by substituting the p value and q value, you'll be getting 11 minus 1 into 5 minus 1. That is 10 cross 4. You'll be getting the pi of function value is 40. So this is the second step. Okay, let's see what is the third step. Okay. Okay, now we have to go for select the value for public E. So E is representing the public key, that is E. Okay, so and the condition is given that key, public key must be smaller than pi of n and is co-prime to pi of n. So two conditions are given. One is the public key should be pi of n, smaller than pi of n, and it should be a co-prime to pi of n. So what is meant by co-prime? It means two numbers that don't share any factors except for 1. Okay. So you have to take for, you have to compare with the 40. So what is the key value, public key value? What is the torsion key value? That value must be smaller than this torsion function value 40, and it should be a co-prime also. Okay. So the prime numbers are listed here: 3, 7, 9, 11, 13, 17. Among those values, we are picking up the E value is 7. So the options are here. Okay, we are going to use the key value, public key value is 7. Fine. So third step, we have to go for selecting the public key value. And the fourth step, you have to go for calculating the D using the following equation. So DE equals 1 mod pi of n. Okay. So substitute the values of E. So E value is 7. Okay. So substitute here D of 7 equals 1 mod pi of n is 40. So substitute that. Now calculate D of 7 equals 1 mod 40. Okay. So at this step, we'll be using the formula to calculate, we'll be using the Euclidean algorithm to solve this, okay? So we put 40 on one side of the equation and find out, so 40 should be at the one side, okay? Okay, so 40 you have to make it at the left side. Okay, then on the right side you have to find out how many times 7 goes into 40. So let's see. So what is the previous step you are having? So in this d of 7 equals 1 mod 40. So in this equation, you are having the value 7 and 40. So with this 7 and 40, you have to proceed with the Euclidean algorithm. Okay. This 40 should be taken on the left side and 7 should be on the right side. Okay. So keep that in mind. You have to find out how many 7 goes into 40. So the answer is 5 and you will get the remainder 5. So how will you write that? So 40 on the one side, left side, and 7 you have to find how many times it goes, 5 times, plus the remainder should be plus that remainder value. 5 is the remainder value and it goes 5 times. So this is the equation we are getting. Okay, fine. Now with this equation, move the 7. So always you have to take the what is the remainder value and the whatever value you are getting, how many times it goes. So 7 should be taken into the left side and find. So the remainder value is 5. Okay, so you have to calculate how many 5 goes into 7. So how many 5 goes into 7? One time it goes. So that you have to put here. Plus what is the remainder value you are getting? 2. Okay, fine. So whatever the value you are getting, you have within the bracket, you have to take on the left side. So 5 you have to take on the left side. And you have to find how many times 2 get into 5. So 2 times it goes. Okay, you put the 2 plus the remainder is 1. So with this you can stop at the last non-zero remainder. So we then use the extended Euclidean algorithm. Fine. So how will you use that? You have to take the 1 on the left side. Okay, fine. So take this 1 on the left side. So 1 on the left side. So that you will be getting 5 minus 2 of 2. 2 into 2. So that will become on the right side. Okay, fine. Now, so at this step, substitute the 2 value here. So what is the 2 value here? You can go from get the value of 2 here. So from this step, second step, you can get the value of 2 as 7 minus 1 into 5 equals 2. You can get this value. Okay. So substitute that value here. Instead of this 2, you can substitute the 7 minus 1 of 2 here. Okay. Now go on with 1 equals 5 minus 2 or 2 into 7. Expand this. Okay. 2 into 7 plus minus into minus, you will be getting plus 2 into 5. Fine. So in this, you are having 1 of 5 minus 2 of 7 plus 2 of 5. So you can go on add this 1 of 5 plus 2 of 5. You can get 3 of 5 minus 2 of 7. Okay. So at this step, you can go on substituting the value 5. So 3 of 5, instead of 5 representing, you can go here. The first step. So now from this first equation, you can get the value of 5 equals 40 minus 5 of 7. Yes. So that 5 value should be replaced in this position. So 3 into 40 minus 7 of 5 of 7. And already you can carry out minus 2 of 7. Okay, fine. Now expand this. 3 of 40 minus 15. 3 into 5. You will be getting 15 into 7 minus 2 of 7. Okay, fine. So minus 7, 15 of 7 minus 2 of 7. You can go with adding. So minus 17 of 7 will come. Okay. So at this step, can I have any response or able to follow me from the participant side? Are you having any doubts in the slide? How you are getting with the Euclidean algorithm and extended Euclidean algorithm? May I proceed? May I have any response? So yes.
Yes, ma'am, we could follow.
Shall I proceed?
Yes, ma'am.
Thank you, ma'am. Okay, fine. Okay, so up to this, you have applied the extended Euclidean algorithm. So you will get the d value as d equals minus 17. So at this step, see here the last step, 1 equals 3 of 40 minus 17 into 7. Okay. So now we have two original values, that is 40 and 7. Okay. So the important number is in front of your encryption key, that is 7. Okay. And you can have minus 17. So if this was a positive number, this would be our decryption key. If this is minus 17 is positive, means this is our decryption key. But because this is we are getting a negative number, so we can go for calculating d equals. So what is the decryption key? Minus 17 is the decryption key, mod that pi of n value is 40. You have to substitute this. So upon using your scientific calculator and calculating minus 17 mods 40, you will be getting the value 23. So now we have to take the decryption value as 23. So the encryption value is taken as a randomly prime number, and decryption value you have to apply Euclidean algorithm and the extended Euclidean algorithm to find the decryption value, that is d equals, we are getting 23. Fine. So this is the fourth step. We have to go for calculating the DE, means that is decryption key. Okay, fine. Okay. So coming on to this table, now we are going to create two keys. That is, the first key is encryption key and the second key is decryption key. Now we have got all the values. E value is 7 and D value is 23. Okay. So put all the values in the tabulation, private key and public key. So public key, you are in need of the n value, that is 55, and E value 77. For private key, you have to list all P value, Q value, totient, that is pi function, and D value. Okay. So this, the result of this, Bob knows n, that is n value is 55, and his public key value E. So this two values can be distributed as he wants. Okay. So Alice can also use N and E to encrypt the message for the Bob. Okay. So both the N value and E value will be shared by Alice and Bob. That's the concept here. Okay. Fine. So now Bob can decrypt the message as he has only the decryption key D and the totient value of the RSA modulus. Okay. So now Alice want to send the message hide. Okay. It has been hidden. Okay. Fine. So hide is the given plain text. Consider hide is the given plain text letters. Okay. Now the equation to find or to convert the plain text into ciphertext. So what is the equation to find the ciphertext? C equals m power e mod n. Make a note of it. M power e mod n. So m is your plain text and e is your encryption key value, that is your public key value, and n is nothing but we have already calculated p into q value, that is your n value. Okay, fine. Okay, fine. So we are having all the values p equals 11, q equals 5, n equals 55. That is n equals p cross q, and pi of n you have already calculated the torsion value as 40. Okay, fine. So take the first letter in your plain text. H is the first letter. Okay, and what is the numerical position of H value in your alphabetical order means you get the value 7. Okay, and substitute this in the formula. C equals m power e mod n. So 7 power 7 mod 55. Okay, so upon calculating this in your scientific calculator, you will get the ciphertext value as 28. Okay, that was the first for H plain text, the ciphertext value will be 28. So the next letter H. So upon encrypting I, the position value is numerical position value is 8, and you'll get 8 power 7 mod 55. Upon calculating this, you'll get the ciphertext value as 2. And next, move on to the next letter D, you'll get 42. And for E, you'll get 49. So for hide plain text, on substituting on the ciphertext formula, that is C equals m power e mod n, you'll get the ciphertext value 28, 2, 42 and 49. So this is the final ciphertext value for hide. Now at the decryption side, you have to take all these ciphertext values and process with the formula, that is m equals c power d mod n. So make a note of this formula. For the encryption, you have to use c equals m power e mod n, and for the okay, so for the decryption, m equals c power d mod n. Okay, fine. So first take the ciphertext, first value 28. Okay, now we are going to decrypt this with the help of the decryption key, that is D. So what is the decryption key? 23. So 28 power 23 mod 55, you will be getting the value 7. Fine. So what is the character position value of 7 is H. So this is our first plain text. So in this way, you have to go for calculating all the plain text value. Next, coming on to decrypting the 2 power 23 mod 55, will be getting 8. So the position value of 8, the character for the 8th location is I. So you'll get the plain text as I. So this is our second plain text. And coming on to 42 mod 23, sorry, 42 power 23 mod 55, you will get the value 3. So what is the character at the location 3 means D. So you'll get the third plain text, and upon encrypting 49, you'll get E as the fourth plain text. So in this way, you're getting back the plain text on decryption. Okay. Okay. So let's have the algorithm as a whole. So choose the large prime numbers P and Q. So that is your first step. So take another example. P can be 7 and Q can be 17. I am repeating with another example. Okay. So far we have seen 4 steps. That 4 steps are put collectively into this algorithm in the slide. Okay, fine. So, and we have seen one example also, hide, how we are going to encrypt the hide plain text, and convert it to ciphertext we have seen with the formula, and as well as we have also seen the decryption part also. So with the ciphertext value we have to apply with the decryption formula. Okay, and once again we can go on with the, we'll be getting the plain text. So that was the thing we have seen so far. Now I am explaining with the another example, that's all. Okay, fine. So first thing, you have to choose the two prime numbers p and q, and second step you have to calculate the RSA modulus, that is n equals p into p cross q. Okay, so after finding the n value 7 into 70, we'll get the n value as 119. Okay, fine. Next, third step, you have to go for calculating the encryption key, that is E. Okay, so select the public key or the encryption key, that is E value. Okay, fine. So such that, okay, such that it is it should not be the factor of p minus 1 into q minus 1. Okay, so we are getting upon applying the formula, p minus 1 into q minus 1 equals, p minus 1 is 7 minus 1 and q minus 1 is 17 minus 1 16. So 6 cross 16 you will be getting 96. Okay, now let us choose the public key value of E. Okay, we are choosing as the public key as 5 value. Make sure that it should not be the factor of 96. Okay, so come on to the fourth step, that is you have to go for selecting the private key. So third step you have to go for selecting the public key. Fourth step you have to go for selecting the private key, which is used for the decryption key, that is called as decryption key D. So the following equation, D cross E mod P minus 1 into Q minus 1 equals 1. Okay, fine. So come on to the right side. So what is the D value here? Let us choose the D value as 77. Okay, fine. And with this 77, because 77 into 5 mod 96, you will get 385. Mod 96, you will get the value is 1. So for that purpose, we are taking the, if you are getting 1, then we can go with the 77 as the decryption value or the private key. So based on the above values, you can consider the encryption decryption process. Okay, fine. For example, A equals B equals A equals 1, B equals 2, goes on. Okay, fine. From this, we can go for taking F equals 6. So consider this 6 is your plain text value. Okay, fine. So what is the encryption formula? It is given here to calculate the ciphertext CT from the plain text as follows. That is CT equals PT power E, that's the encryption key value, mod N. Okay. So what is the PT value? You are getting 6, plain text value, position value. Okay, fine. So 6 power 5, E is, the value of E is 5 here. Public key value is 5. So 6 power 5 mod N is the 119. Okay. So after calculating, you will get the ciphertext value 41. So this is on the case of encryption. If you move on to the decryption part, you have to go with the calculating the plain text from the ciphertext. So PT equals CT. So you'll be having the ciphertext with that. And now apply the decryption key, that is D mod N. So CT value is, we have calculated as 41. So 41 power D value is 77. Mod 190. You will get the plain text value as 6. So in this way, you have to go for encryption and decryption by using the following algorithm steps. Okay. Okay. So Alice will be using the public key 5 value, and Bob will be using the private key, that is KD equals 77 for decryption purpose. Okay, this what's the concept, how the Alice and Bob can transfer their key values. Okay, so I have winded up with the one algorithm by today's session. Okay, this was the references used for preparing the slides. Okay, so you can also go on with working out some other problems also. Okay, you can search on the net and go and work out using this algorithmic steps what I have taught in this session. Okay, thank you, students.